Hi, thank you for your interest in my work. I'm going to be presenting on the methods we can use to assess human mobility patterns within cities and how we can use these methods to make sense of depression rates. I'm going to be giving a brief overview and I'm happy to answer any questions at the end. Currently, 55% of the world's population live in cities. This number is going to increase so that by 2050, nearly 7 out of 10 of the total world's inhabitants will share the experience of city living. Because of this, it becomes pivotal to understand how urban environments affect the lived situation of the individual, how cities make us feel, how cities foster social interactions, how we move in cities. The focus for us has been how cities impact mental health. The research conducted was a continuation of the study Evidence and Theory for Lower Rates of Depression in Larger U.S. Urban Areas, conducted by my mentor, Andrew Steer. The study found that large U.S. cities have lower rates of depression compared to their smaller counterparts. Additionally, the study found that depression shares mechanisms with other collective phenomena like infectious disease. Infectious diseases spread primarily via social interactions. Thus, variations in human mobility patterns within cities may be particularly important driver of social interactions and consequently depression rates. My research entailed discovering how exactly we can measure human mobility patterns within cities. From mobile phone data to the tracking of dollar bills, there are a multitude of methods that can be used to measure human mobility. We decided to use data sourced from Twitter because it allows us to infer depressive sentiment from language use and get mobility measures at the same time. For each user, the academic Twitter API gives the text, longitude, and latitude information for every tweet produced. So when an individual user moves, each new location is recorded. Yet the route that the user takes is not recorded. Originally, we calculated these routes using as the crow flies different distances. As seen in Figure 1, this is a gross underestimate of the total amount that each user moves. City networks are constructed around geographical barriers, not the individual. Our estimates had to account for these networks and the man-made streets, tunnels, bridges, overpasses, etc. that are within them. We used OSMNX to fix this issue. This is a Python package that allows us to plot the shortest route through a city network between two coordinates. We decided to characterize human mobility using three measures: total distance traveled, average distance traveled, and the radius of gyration. The total distance traveled is the sum total of all the trips taken by the user. The average distance traveled is the total distance divided by the number of trips. The radius of gyration is the characteristic distance traveled by a user within a specific time frame. As seen in Figure 2, the radius of gyration is an intrinsic reference frame for each user, and it allows us to compare users that have vastly different total distances. I spent the year developing the code we can use to compute user mobility measures in Chicago. In Chicago alone, these methods are human mobility measures. In Chicago alone, these methods will be expanded to 56,000 Twitter users and 3.2 million tweets. We will also use it around the US and the globe. Although we're still in the process of applying these tools to our entire dataset, I was able to calculate the metrics for one user in San Francisco. I found that not accounting for street networks results in a 28,000 meter underestimate of this one user's mobility over the course of just a few months. We will be using these methods to discover if people who have lower rates of movement who move more have lower rates of depression. We will also see how depression rates vary in cities and assess whether neighborhoods with less access to city networks, like public transportation, for example, will have higher depression rates. In the future, we hope this research can help guide policymakers to deploy healthcare resources in areas with higher rates of depression.